This is where the majority, this function is where the majority of the, the calculations um, for calculating the charge start time happens. And it's writing back and forth, it's writing to the Google Sheet that I had shown in a previous video. Here's a glimpse back at it again, which puts in a bunch of pertinent information and then figures out between the two cars when they should start charging to finish at 6 a.m. In my case. And so if you go back to the function, this one called write start times, I start by declaring an array, which is a place to store all the input variables that I'm going to write into the Google Sheet. And the reason I use this method versus writing it one value at a time is because it's more efficient. There's a batch version of the command I'll show at the bottom of the function that you could submit all the updates at one time. It's much more efficient. I mean, it's negligible, but it's just better to, I think, less chance of failure, and plus you just get all the updates there in one time. So, and the other thing to note about this is, as I scroll through this, is that this will call out to both vehicles to get information. And the reason I need to do that is because this has to be run in parallel, or excuse me, they has to be all run together in one function, because this calculation is dependent on the fact that it has information from both vehicles so that it can accurately determine which one should charge at what time. If it doesn't have that information from one of the vehicles, or it runs at a different time, then the calculation would be off. Obviously, if I only had one vehicle, this wouldn't be a problem. But for two, it needs information for both vehicles, which is why, again, it needs to run both of these vehicle checks at the same time. So the first one in this try catch block, and I put them separately because remember, if one car is asleep, it needs to send a command to wake it up and then rerun the command again. And I'll show that at the bottom. So the first thing I do is inside this try catch block is I go get the charge state, and that's using a function earlier that I showed, and passing in the Model 3, in this case the vehicle ID. And once I get the data back in this JSON object, there's a function in Google application scripts that parses that into an object that you can use. And so I start to populate the input object. So you can see here the syntax. There's a push command to put the item into this array, and you first pass it a range. And so the syntax is the name of the sheet and then the cell number. So if you see here, this one, the value is the battery range. So if you go back to the spreadsheet, so if you remember Smart Charger B10, so Smart Charger is this tab, and then B10 is this field. So it's going to update this field, which is the Model 3 current state of charge in miles. It's going to do that with this command. And then you see it goes down. Next thing I do is I put a date timestamp on the field next to it, or a couple of fields down in column D, row 10. And again, right over here, column D, row 10. This is the timestamp in which this data was drawn and executed. And so I just use this command, which is a new date to a local string, and then I do the same thing but to a time string, excuse me. So I know exactly when this was last updated. The next row is the scheduled charge time. So in row E28 here, or excuse me, cell E28, so in the Model 3, E28. So this is in a millisecond format. And so this I used to use this. This is not actually important for the calculation, but this just reminds me when the car is actually scheduled to charge. You know, I used to use this information just to compare, but like I said, it's not really important. But I figure since I have the API, I can grab the data, so I can look at that information. And so that's actually the time in which it's scheduled to charge. And then the charge limit, which is what I've set the charge to in the car, through that bar that shows looks like a battery. I write what it's currently set at, and that one's called charge limit SOC, state of charge, divide by 100 to get a percentage. And so in here is cell B16. So B16, that's what's one, Model 3. And this one is, yeah, I said it, as I said earlier, at 70%. If you go back here, so that's the charge limit, and then the max range. So this is an interesting kind of theory, I suppose. Before I would use just the stated range of whatever the car is at. I think the Model 3 long range rear-wheel drive is 310 miles. But I noticed that that varies from time to time. The calculation is not precise. So what I thought would be more accurate is that I would get the value, the maximum battery range, based on what the car thought was the battery maximum at that given point. And so how I do that is I get the range that is read from the API, and then I get the battery level, and I divide the two, and then divide by 100 to get the proper the estimated max range. So I put that in cell B6. So you go over here, B6, the max range. So you can see that it's not exactly 310, and this method is not perfect too, because it seems to vary, hour by hour, minute by minute. But I figure instead of fixing it over time, because as you know or may know, the battery degrades over time. So I wanted to use the more accurate figure as the car reads the information, versus me just fixing this at 310 at a constant every single time. So that's the reason why I chose to do that calculation and store this quote unquote max range. So that's how I figure this value out, and you can see how I use it later. And then I'll use this data to also write into another sheet, because since I took the trouble of calling the API, there's another sheet that I'm going to write this to track the battery degradation. So on a different sheet in this Google sheet, there's a field here. Let me see where it is. So it's telemetry, and it's in the M row. So over here, this is the battery capacity. So I track it over time. So it gives me a sense of degradation. And so there's a little function here that I skipped over. So I'm appending this Google sheet, which is like a running total. So what I do, there's a function I have that basically looks through the spreadsheet and figures out where an empty spot is, and then just writes it underneath that, so I don't end up overwriting any data. So that's what this function is called, find open row. I give it the spreadsheet ID, and then I tell it sort of where the column is I should look and which sheet, and then it returns a number. And then I essentially do the calculation, figure out, okay, so it's in this row, but I said column, it's column M, but it's going to return me a number that says like row 50. So I know that one's blank, and I'm going to write to that row. So that's what this function does. So that's how it knows where to put that value. And then there's this function, which then to save me the trouble to automate this, I can copy formulas down. Again, this is partially the reason why I was attracted to using a Google Sheet, because it made it easier to create on-the-fly formulas and make adjustments to my calculations. So you could see here that when I use calculate the battery capacity, I write it in. There's a formula here that it gets copied down. So this is what I take. Maybe you can't see it in the cell above, but I basically take this number here on the left and divide by the stated range, which is 310 miles. And so you can see why sometimes if it's above 310 miles, it's a higher percentage. It's technically not possible, but the degradation is negative, if you will. And then sometimes, some days, you can see here on July 14th, for some reason, the battery thought that it was less than 310, and so therefore the degradation was 99.6. And you could see in the chart that it's not, it wobbles around a lot. So this is the chart that is battery degradation. So you can see how it kind of just hovers, up and down between 100. So I'm sure you can get an average from that, but it's just kind of an interesting data to see how that trends over time is probably what you're going to be most interested in. So that's this calculation here, which copies that formula down. And as I mentioned earlier, I have this in a try-catch block because I'm reaching out to the car anytime I call the API. It could be asleep, and so if it is, I need to catch the error, wake the vehicle, wait 30 seconds to let it fully wake up, and then I restart the sequence to run these calculations again. And then I also do this for the other vehicle, the Model X. So this is exactly the same thing, but using different separate fields on the Google Sheet. and then I run it through. And only at the very end do I do the batch update. So this is the command to do the update. So only if it passes both vehicles and then I write the data all at one time. So that's why they're in separate catch blocks, and that's why it's run all together at one time. So that's how this sheet is populated over here, that does all the calculations. I mentioned earlier there's other formulas in here that figures out, these are like spreadsheet formulas that figure out, okay, if I were to charge at half speed, how long would it take? And then I figure out which one takes the longest, and then that's the one I start first. So I covered that in a previous video, but that's how I did this using a Google Sheet. Again, you could do this in the Google script as well, but I figured it was easier to do this in a spreadsheet. It's easier to manipulate and play around with it versus doing it in code. It's a little less forgiving, and in a database, of course, as well. So this allows me to manually manipulate it too as well if I want to play around with it to adjust the numbers as I go. So now that we've written the start times, all the information to calculate the start times from the Google Sheet, now it's time to look at the functions to to actually schedule the charging times. And there's a couple things to note. So in the car, and I showed this earlier, how the car was set to 5 a.m. even though I wanted to finish at 6 a.m. So to setting it at 5 a.m. so that it doesn't start prematurely. Because if I set it at midnight, then the car will start charging at midnight, irrespective of whatever I set in here. So I set it to essentially the lowest or the latest time possible, in my case probably 5 a.m. And also that creates a little bit of a buffer, just in case the car, this doesn't work, the car will still pick up and start charging at 5 a.m. If it's already charging, nothing happens inside the vehicle, it'll just, it'll ignore that. But if it happens to forget, it'll start charging by itself at 5 a.m. if it's below the battery, set limit. And it turns out actually last night it failed on me for one of the cars for some reason, and it started charging at 5 a.m. And again, I mentioned earlier I don't really need to charge every day, but having that buffer is nice too. So I charged for another hour or so, 2 hours almost, and it gave me almost back to the full charge state of 70%. So it works out anyway if you miss it. So that's why I set it at 5 a.m. And then that's in the vehicle. And then these two functions for each vehicle, I will start to read from the Google Sheet, which I had written to earlier. So you can see how I'll read the target and current state of charge. So B18 and B10 for the Model 3. So if I go to the spreadsheet, B18, that's what I want to charge it to. And then B10 is what it's currently at. So that's these two variables, current and target state of charge. And then I'm doing an evaluation here that obviously, if just like the vehicle, if the target is larger than the current state, meaning that I'm currently less than what I want to be at, then I'll execute this block. Otherwise, there's no point. It's like setting the limit below the current level, so there's no reason to charge. It can't charge it. So if the target is larger than the current, then I will get the start time. So E26 here. E26 is down here, and like I said, the spreadsheet calculates this. I found it easier to do that, but here's the exact time. It's going to charge at 3:18 a.m. And so I go over here, and there's probably a smarter way to do this, but at the time, this is how I figured it out. So in the trigger, when you set the trigger, you have to put a date and then AM or PM. So I figured out, well, I'm going to look at this sheet, and if it says AM, then I'll write the date as tomorrow, right? Because I have this on a timer to run late at night, but not past midnight. So late at night, before my PG&E time of use plan, which starts at 11 p.m. So it runs around like 10 p.m. And then so if it says AM, then it'll set the date to tomorrow, which that's what AM means, obviously. So after midnight. So that's how I have this variable tomorrow date. So I take today's date plus 24 hours, and then I use that for the date, and then I'll use the start time as it shows, which was what was it, 3:18. And then if it doesn't say AM, then it'll put today's date, because then it'll be somewhere around 11 p.m. or earlier, presumably, and it'll put today's date with that start time. And then once I figured out the AM/PM business, then I'll actually create a trigger here that has, I just name it charge that vehicle. This is you can do this manually in Google Apps as well, and then it sets the time and it creates that trigger. And I actually did have a function earlier to delete the triggers, but it turns out that after 24 hours, because these are one time set to run exact time, they expire the moment they're run, it deletes by itself in 24 hours. So that's actually pretty cool, so I don't have to do any cleanup or deleting. And you can see here I do the same thing for the other vehicle, the Model X. So that's why it's also, like I said, it's important to have that function earlier to run at the same time, so that when it sets the charge time, it knows the calculation for both vehicles. And if it happened not to run for one, it's going to be inaccurate. So that's why those two vehicles have to be run in that one function at the same time, or in the same function, I should say.